We'll begin our discussion of functions with a very foundational question. What is a function? So the definition I want to use is that it's a mathematical object that sends an input to a unique output. So this idea of the unique output is really the most important property here. I can discuss relationships in which an input have multiple outputs. Those can be very reasonable depending on what you're talking about. That is not what a function is. Function has one output corresponding to my input. The two different inputs can go to the same output, but one input, one output. We will typically think of them as numerical, that I'll be handling numbers, number in, number out. But the basic idea applies to things that don't have to be numerical. What about notation? Well, we've already seen some notation in Module 1, where we use this notation f of x. This describes the idea that I input a value x, and then I follow some rule given by f that tells me how to compute the output. This is an abstract way of thinking about it, but it's very convenient for mathematical computations. So the key idea when we're thinking about visualizing functions is, does every input correspond to a unique output? Or can one input have multiple outputs? The way this is typically addressed is something called the vertical line test. It's very nice. All you have to do is look at a picture of the purported or claimed function and check. Every vertical line that I draw on this plot, does it hit the function at most one time? If the answer is yes, then it's a function. If the answer is no, it's not a function. The idea is that if a vertical line intersects the plot in more than one place, that means at that input value, I have multiple outputs because I intersected more than one time. That means it's not a function. So the vertical line test really gets to the heart of the matter about what a function is. So let's look at some examples. So here I plotted a parabola, and I asked, does it pass the vertical line test? So I draw some vertical lines, and it does pass it. Each line intersects the plot only one time. Conversely, I plotted a circle on the left. So I look at different x values. Boom, fail, fail, fail. In multiple places, this plot fails the vertical line test because the line intersects the plot in more than one place. So this is not a function. Here I've just drawn it again. The key point is that here I have only one intersection, right there. Here I have multiple intersections. All you have to do is find one vertical line that intersects the plot in multiple places and you fail. So let's do an exercise where we try to plot different mathematical relationships and then use the vertical line test to see if they're actually functions or not. So we'll start with a real easy one, y equals x plus 1. So I'll plot some values. If I plug in x equals 0, I get 1, minus 1, 0. So if you're still a little uncomfortable about plotting lines, you can always plug some values into this table. Okay, so here's my plot. And I ask myself, is it the case that every vertical line I draw intersects the plot at most once? You can maybe see from the picture we've drawn that the answer is yes. But I'll draw some lines just to help us out. Here's one vertical line, only one intersection, 1, 1, 1. So it passes the VLT, the vertical line test, implies this is a function. Here's one. X equals the absolute value of y. Now we know what the function y equals absolute value x looks like. We saw this in Module 1. Here I switch the roles of x and y. So maybe you already know what this looks like, but if you don't, let's plot a few values. Right. So when I plug in, let's say y equals 0, x is equal to 0. When y is equal to 1, x is equal to 1. When y is minus 1, x is also equal to 1. So let's just start plotting some of these points. 0, 0, 1, 1, 1, minus 1. So I get the familiar V shape, but rotated. So now the V is sort of straddling the x-axis instead of straddling the y-axis the way it did for y equals absolute value x. So we ask ourselves, does this pass the vertical line test? Well, let's draw some vertical lines, shall we? Oh, wow, immediate failure. The first line I drew failed to satisfy, right? It intersected the plot in more than one place. So automatically, it's not a function. Because it fails the vertical line test. And we'll look at one more example. X equals y cubed. Now in module 1, we saw the picture of what y equals x cubed looks like. But again, I've switched the roles of x and y. In the previous example, that was a big problem. It went from being a function to not being a function. Is that true here as well? That if I switch the roles of x and y, it fails to be a function? Well, let's look. So if I plug in y equals 0, I get 0. Y equals 1, 1, minus 1, minus 1. Y equals minus 2, I get minus 2 cubed, so minus 8. If I plug in positive 2, I get positive 8. So I'll start plotting these points. Need to go out a bit further on the x-axis. So the picture is something like this. Okay, and in fact, does this pass the vertical line test? Well, it sure looks like it. All these vertical lines are only hitting the plot in one place. So this actually does define a function. It doesn't look like it, maybe without plotting it, but it does. So the key idea of the vertical line test is that it gives us a nice, simple geometric way to determine whether a mathematical relationship is a function or not. Of course, it requires you to do some plotting. So it's, again, something I would recommend getting in the habit of. Knowing the shapes of these basic mathematical relationships. It's an incredibly valuable skill.